Question 5, phytoplankton. Wow, always a popular topic. Some people do their PhDs on this. And they are a bit toxic to shellfish. So you eat those, you've got algae toxins in, and that can poison you. Don't eat shellfish, that's the answer. And they are trying to work out how many phytoplankton or algae they've got, and so they catch them in a net towed by some sort of boat. That's pretty straightforward. These are the ones that they're trying to catch. And what mesh size would they use? Well, the mesh size needs to be, well, let's say we had a 50 mesh size. It would catch this lengthways, but these, if that went sideways through it, how big's that? That's not 50. What about this one? Anything that is the hole, if the hole is bigger than that, then this is going to get through. So we need to estimate how big that is. So we'd go for something like 10 micrometers. So if that's 1 centimeter, and that is 2 millimeters. That is 10. So that is 10 millimeters, and that is 2 millimeters. So I need to. It's a fifth of 50. A fifth of 50 is 10. That's where we're getting that from. So that is 50 divided by 5 from my diagram there. Our reasoning for this, the mesh size needs to be smaller than the widest part of this algae here. So mesh needs to be needs to catch this less than the widest part of pseudo, less than the widest part of pseudo. What a great names in this exam. Pseudonychia. Try saying that when you're not drunk. And presumably if it catches that one, it's going to catch those and catch those as well. Here's some data. Use a data state which has got the greatest biodiversity. So think about the definition for biodiversity. It's how many species there are present. That's the species richness, and then how many individuals of each species there are there. So how many species have we got present? They've both got that one, yeah, you're trying to just ignore the zeros there. Oh, so they've both got 4. So species richness is the same. So 3 marks here, so we're going to try and put down our reasoning here. 3 lines. So, both have 4 species present, which is the species richness. But site 2, 49,000. So that is, if you were kind of putting these, so most of them are that one, whereas here they appear to be a bit more spread out. So we need to put a line just explaining that. So site 2 is dominated by 1 species. Site 2 is dominated by one species. Whereas site 1, which is actually answer the question, site 1 has greatest biodiversity. Name a statistical test. Well, you've done this on your fieldwork. It's the Simpson's Biodiversity Index. And you've done some calculations. That's in your lab book. The 2-site sample shows significant variation in distribution. So in any experiment, you're going to get variation. If you measure people's heights, you get variation. Boys versus girls' heights, you get variation within the boys, variation within the girls. How would you improve that experiment? And it says to further investigate along the stretch of coastline. So at least a couple of. Now I want to do more repeats, more results, and then I want to do more along the coastline. So there's at least a couple of ideas. So let's deal with this coastline one first. So more locations along the coastline. So sample more locations along the coastline. And then the kind of more repeats, well, we could do it more than once a day or more frequently. I think they were doing it once a day. Yeah, they were doing 2 different sites, same day. So sample more than once a day. So more, the idea of more sampling. And how else could you increase the sample size? Well, you could, how much water are you putting through this net? You could do more. So you could look at this and go with a bigger net or do it for longer. That sort of idea. So increase the volume of water sampled or sample, drag the net for longer, or some idea of other way of increasing that sample size. And then they use this to inform the shellfish industry about problems, and we're given a chart with average water temperature. As soon as you see anything with temperature, you think, well, it affects enzymes, growth and things like that. Explain why monitoring takes place more frequently between March and September. So March and September, so between March and September, start looking at that area. So higher temperature. And of course it's summer. So higher temperatures, it's summer. And so we're gonna, why are they concerned? Why are they really concerned in the summer? Well, because this phytoplankton, more high temperature, more phytoplankton problems. So more growth of phytoplankton. They reproduce faster, so more risk to humans, or certainly the shellfish humans that eat these things.